Hey guys, good evening. Thanks for joining. I see a couple of comments here, so let's see. Good evening, everyone. Good evening, Satya. Good evening, Kush. All right, let's allow people to join. Let's see how many folks join. A lot of folks are promised, so now it's 7. Let's give another 5 minutes. Yes, good evening, Janika. How are you doing? The photogenic bug, good evening. What's your real name? So I see 3 participants. Let's wait for the others to join. Any specific questions if anyone wants to address? Aisha, yes, good evening. How are you doing? So we are waiting for some more participants to join. Are you guys able to hear me? Like, am I audible? You just confirm in the chat. Okay, perfect. Payal Chirag, okay, new participant. All right, that's good that we have folks joining. Yeah, let's wait for more. Let's give another couple of minutes here and there more. Some more people have promised to join. Yes, Pramod, I see your comment is first. So let's begin in the next 1 minute. All right, so let's begin the session. So, welcome to this live session. On your behalf, on your request, I have conducted this live session to uh, familiarize you with the concepts of calculus, right? Which is one of the fundamental topics in mathematics. Um, let's do one thing. Let me share the whiteboard, and then maybe we can discuss the concepts in detail. So, just confirm if you can see my screen. Yes. Okay, perfect. So we discussed that the derivative is basically like dy by dx equals limit h tends to 0 f of x plus h minus f of x divided by h, right? So essentially, if the graph of a function is like this is x and this is your y, this is basically your f of x, right? And if it looks like this, then the rate of change of a function is basically your y2 minus y1. This is your y2 and this is your y1 divided by your x2 minus x1, right? This is equal to y2 minus y1 divided by x2 minus x1, which is delta y by delta x. Then this derivative is basically such that this interval x2 minus x1, this goes on decreasing. Like this is one triangle, but then it becomes smaller and smaller and smaller, right? This triangle starts becoming smaller and smaller and smaller until this x2 minus x1 tends to 0. So like it becomes a small point over here. So delta y by delta x becomes dy by dx, which is basically the instantaneous rate of change, right? Rate of change. That's essentially f of x plus h, which is your y2 minus f of x, which is your y1 divided by h, right? So your y2 and y1 are going to be close enough now. This is your y2, this is your y1. That becomes dy by dx. Clear, everyone? You just confirm in the chat, right? This is clear. Okay. You just say yes or just give me a thumbs up in the chat if it's clear. All right. So, suppose this, based on this formula, we understood that basically if this is true, like limit h tends to 0, then basically derivative at a particular point, it will be basically a tangent to drawn, right? A tangent, the slope of that tangent, right? So tan of this theta with the x-axis, right? That's the derivative. Okay, and then we saw like the derivative of sine x is cos x. Derivative of cos x is minus sine x. Derivative of sec x is sec x into tan x. Derivative of tan x is sec square x. Derivative of cosec x equals cosec x into cot x, right? Right, like this clear, everybody? So now let's do one thing. Let's solve some problems based on this knowledge, right? Then we also discuss the chain rule, right? Dy dx of f of g of x is basically df by dg multiplied by dg by dx, right? And then the product rule is basically d by dx of uv equals u into dv by dx plus v into du by dx, right? And d by dx of u by v equals v into du by dx minus u into dv by dx divided by v square. Right? So using all of this knowledge, let's solve some problems now. Right? Let's take the first problem. Say y equals x into sec square x. Find out dy by dx. That's the question. Okay. Clear, everyone, the problem? Okay, let's take 2 minutes to solve this, and then you can maybe discuss your answer, or maybe you can just mention that in the chat. Right? Yes, anyone wants to go? Chanika, what's the answer? Any responses? Yes, please. Okay, Janika is saying sec x into 1 plus x tan x. Okay, let's see what the answer is. Okay, let's solve it together, okay? So this is your u and this is your v, right? Let's do it that way. So it's basically d by dx of u into v, right? So it's u into dv by dx plus v into du by dx. So what is u? X into d by dx of sec square x plus sec square x into d by dx of x, right? So x into what is d by dx of sec square x? It's basically 2 into sec x, right? This is your chain rule, f of g of x. 2 into sec x and then multiplied by derivative of sec x, which is sec x into tan x, right? And plus sec square x into d by dx of x is 1. So this becomes sec square x itself. This becomes 2 into sec square x into tan x into x plus sec square x, okay? Right? So this becomes, take sec square x common now. So sec square x into bracket 2x tan x plus 1, right? That should be the answer, I guess. Okay. Or am I missing something? Okay, yeah, that's the answer, right? Right, Janika? Clear? Yeah, that's fine. Right, let's take the next problem. Maybe we can wrap this session in the next 10 minutes because let's solve the next one. Y equals e raised to 3x divided by x raised to 4 plus 1, okay? So find out dy by dx. I'm just giving you a hint here. You have to use the quotient rule, right? D by dx of u by v, which equals v into du by dx minus u into dv by dx divided by v squared. Okay. Yes, Shanika, what's the answer? Let's do it, right? This is your u and this is your v. So x raised to 4 plus 1 into d by dx of e raised to 3x minus e raised to 3x into d by dx of x raised to 4 plus 1, the whole divided by x raised to 4 plus 1 bracket square. Okay, this thing. This comes out to be x raised to 4 plus 1 into, what is the derivative of this one? 3e raised to 3x minus e raised to 3x into, what is the derivative of this? It's 4x cubed, right? This one is a constant, so it's going to be 0. Okay, the whole divided by x raised to 4 plus 1 bracket square. Finally, what do we get? Let's take e raised to 3x as common outside into bracket x raised to like 3 into x raised to 4 plus 1 minus 4x cubed divided by x raised to 4 plus 1 bracket square. That's the final answer, right? E raised to 3x, I'm just reading your answer, Janika. E raised to 3x into 3x raised to 4. Yes. Plus 3. Correct. Correct, Janika. Your answer is correct. Perfect. Congratulations. Okay? That's right. Okay. Let's take the next problem. Now let's look at implicit differentiation. Okay, I think we covered this concept, but we didn't get a chance to solve a problem. Let's solve it now. Let's say you have an equation x cubed plus sine y equals y squared plus 5. Right? Find out dy by dx. So what is implicit differentiation here? Here you do not have explicitly mentioned like y equals some f of x. You don't have it here. It's a mixed equation here. You have x and y on this side as well and y on that side as well, right? So you have to find out dy by dx. Okay. How do you do that? What happened, Janika? You're trying to say something like. Okay, so how we do this is like this. We differentiate both sides with respect to x. Okay, we take d by dx of both sides. So d by dx of this side is d by dx of x cubed plus d by dx of sine y equals d by dx of y square plus d by dx of 5. Okay, what is d by dx of x cubed? It's 3x square, and d by dx of sine y, cos y, right? But it's cos y into dy by dx. Okay, using the chain rule. You compute the dy by dx, I mean d by dx of sine y first. So d sine y by dy into dy by dx. So cos y into dy by dx, okay, equals d by dx of y square is again 2y into dy by dx. plus d by dx of 5 is 0, right? So this becomes 0. Okay, so now what you do is you take this dy by dx common. So 3x squared equals dy equals 2y minus cos y into dy by dx. Okay, so dy by dx equals 3x squared divided by 2y minus cos y. That's the answer. Okay, clear? Clear? How do you solve this, Chanika? All right. Perfect. Okay, let's take the last problem, then we can close this. Okay. Like y equals x raised to root x. All right. Find out dy by dx. Right. Clear? Try to find out this. Find this out. Yes, Nandini. Good evening. So if you're keen to learn calculus, this session was for you as well. There's going to be a recording at the end. So this session is going to be recorded, so you can watch the recording later. Okay. If you want to solve problems, you can solve. So this is the last problem now. But if you have any questions, you may ask later. All right. So how do you solve this? You take log of both the sides. And just keep this in mind. In calculus, log is always log to the base e, all right? Log of x to the base e always, okay? The base is always e. So in calculus, it's written as ln. So log to the base e is always written as ln. So log of 10 to the base e is written as ln of 10, all right? Log of y to the base e is written as ln of y, right? So ln of y equals ln of x raised to root x. So using the laws of logarithms, you know, right? Like log of anything raised to anything is equal to basically root x into ln of x, correct? So ln of y equals root x ln of x. So now take dy by dx of both the sides. This becomes, what is dy by dx of ln of y? It's 1 by y into dy by dx, right? Equals, now the product rule here, root x into d by dx of ln of x plus ln of x into d by dx of root x, right? This equals root x into 1 by x, right? D by dx of x is 1 by x, right? Plus ln of x into, what is d by dx of root x? Root x means basically x raised to half, right? Ln of x into half x raised to half minus 1, which is minus half. Which is basically x raised to 1 by x raised to half. So it's equal to, so what does this become? This becomes 1 by root x plus ln of x into 1 by 2 into 1 by root x, right? Clear? So this equals 1 by root x into bracket 1 plus ln of x by 2, and this equals basically 1 by y into dy by dx. So dy by dx is nothing else but y by root x into 1 plus ln of x by 2. All right, that's dy by dx. Clear? Yeah, so Chanika, a log is basically log to the base e always, okay? So always keep a practice to write ln whenever you solve calculus problems, right? Write ln instead of log, okay? Because it's log to the base e, all right? Okay. So this also can be expressed in a different way, right? So y is basically x raised to root x. So basically dy by dx is x raised to root x divided by root x, right? Into bracket 1 plus ln of x by 2 as the final value. Here, Chanika. Perfect. Okay, so I think you're in good practice now of these derivative problems. I think you're in a good position to solve them, right? Just keep practicing. Yes, Nandini, any questions on calculus? So people from a different university, they also have their own subjects, right? So these sessions are meant to address those subjects as well, just like people from your university uh, have their own subjects, right? Okay, so it's an all-purpose channel meant to solve problems for everybody, right? Perfect. All right. So any further questions, Chanika, Nandini? I hope the session was useful, right? So unlike for university sessions, I think here we have the leverage of we don't have to wear any uniform, so I can be my casual self here. So yeah, thanks, Nandini. Thanks a lot. All right, perfect. So yeah, if required, let's maybe have another session midweek, maybe Wednesday or something. I'll maybe post it on my channel if people want it, right? Uh, so until then, yes, take care. Yeah, next live session, maybe let's have it midweek or something, like Wednesday or on some different topic. Maybe AI or machine learning, right? Agents or something like that. Let's see. Python, Python coding, or maybe the same calculus. You never know, right? All right, guys. So yeah, have a great time, and I hope the session was useful. See you next time. Bye bye. Yes, thanks, Nandini. Thank you so much. Bye bye. Thanks, Shanika, as well.